the professionals who have logged in, especially students and academic faculty also who have joined us. In fact, this is a good opportunity for students also to upgrade their knowledge. If they take it very seriously and listen to it very carefully to the series of webinars that we have been conducting, I think it would be of use to all the students as well. So this is the 4-day seminar that was organized, in fact, in collaboration with ACCE Chennai Center, and we have already finished the first 3 talks which were there, and today is the final talk on an interesting topic on repair and rehabilitation, which I am sure that many of you would have faced. So before I go to the 80th webinar, let me just give a brief overview of the organization. Of course, both the associated organizations, Association of Consulting Civil Engineers, as all of you know, is a professional body of consulting engineers which was founded in Bangalore, and we have a lot of professionals who are a part of this group. At Ramco Cements, we have been introducing various types of cement based on applications, and we have the Ramco SUPERCRETE cement, which is a blended cement specifically for concreting works. That is what we have been doing for high performance concrete. We have been recommending Ramco SUPERCRETE, which is having the twin advantages of a low heat of hydration and a high rate of gain of strength of concrete, which most of you would be getting. High compressive strength is one of the key parameters that is needed for concrete, and we are ensuring that it is there. And of course, high workability, which is there for concrete in fresh state, because until unless the concrete is not workable, we find that it doesn't go into the congested steel reinforcement, or for that matter, even normal reinforcement also. So that is being measured by using the slump cone test. And of course, durability, which is not being given that much importance. It is not being quantified and measured in many of the construction sites. So we ensure that durability is also there in Ramco SUPERCRETE cement, because it is one of the most important parameter. And we do a lot of works at our Ramco Research and Development Center at OMR Road near Thoraipakkam, where we do a lot of testing on cement as well as concrete mix design, a lot of database on that with various chemical admixtures. Of course, this is one of the tests that is being used for checking the durability of concrete, the rapid chloride ion penetration test. As all of us know that it is based on the amount of charge that is being passed to the concrete specimen. Please, especially for students, you need to have a look at this test, which is very interesting. Of course, it gives an indication of the durability of concrete structures. As all of you can see that the charge passed, if it is greater than 4,000, it is not durable. And if it is less than 2,000 coulombs, it is durable. So compressive strength alone is not an indicator of durability, as can be seen from this test. And we also have the water permeability test, which is being used in many of the project sites for checking the durability of concrete, and they have their own specification. Of course, the water penetration should be less than the cover that is given to the steel reinforcement bars. So based on this, at our organization, Ramco Cements, we have always, vouch for this right product for right application, and that is where you will find 12 brands of cement. Those of who are having RMC units or having a batching plant at site, they normally go for ordinary Portland cement, where they can blend with blending materials as long as good quality blending materials are available. And in that we have 43, 53, infra 43, infra 53 grade. This infra cement was specifically customized for high slump retention, because we got a lot of feedback from customers in major cities where they were transporting concrete, and then for a high rate of gain of strength. Then we have the Portland Pozzolana cement, out of which you have Ramco SUPERCRETE, Superfine, Superplus, SUPERCRETE specifically for concreting applications, which has been made. And then we have the Portland slag cement, the Ramco Super Steel, the Ramco Samudra, and the sulfate resisting Portland cement. So that is the basic idea of having all these types of cements. And we also have the dry mix range of products, which is being manufactured from our dry mix plant for various non-structural applications. Of course, various kinds of awards which we have received for being environmental friendly, for having introduced technology at various stages of manufacturing, and our customers, large project customers who have been using concrete in various exposure conditions and for various types of concrete as well. So that is one thing, and this is what an overview of the webinars that we have conducted in association with ACCE Chennai Center over the last few days. Dr. Tirunakar sir, ACCE Chairman, Chennai Center. In fact, Dr. Rajedran, who is the Secretary of ACCE Chennai Center, they have organized a very good combination of speakers. As you could see that we had the first talk on 3D printing technique and its application on concrete construction on 13th July. It was by Dr. M. Shekhar, who made the subject very simple and helped all of us to understand as to what goes behind it, what are the pros and cons of it, and that being in the research stage. And the second talk was on foundation failures, causes, prevention, and remedies by Engineer Karthikeyan, who in fact had a lot of analogies and made the subject very interesting to all of us by making various comparisons. And the subject was made very light, and I am sure that students would have enjoyed his talk. Then we have Dr. Colonel Nalathambi, who gave the talk yesterday on good construction practices in RCC buildings. And he gave a comprehensive talk on the various practices that can be adopted for making a good RCC building. And if you don't follow that, what happens is ultimately we need to go in for repair and rehabilitation. And that is what today's topic by Dr. V Rajedran is all about. And of course, next week we have again 3-day national webinar series organized in association with IEI Telangana Center, starting from Monday. We have Innovations for Sustainable Development by Dr. KVL Subramaniam on 20th of July. The second talk by Dr. V Bhikshma on importance of special concrete, geopolymer concrete, and the earthquake safety of tall buildings, some salient provision of IS 16700 is on the third day, that is the 22nd July. So there is a lot of talks that have been organized, and students, faculty, and professionals, budding professionals should make use of these talks. Now, before going to the talk of the day, let me just introduce the speaker. Before that, I would request Dr. Tirunakar sir to give away the welcome address. Welcome all of them on behalf of ACCE Chennai Center.
It has not been agenda. Dear operator, engineer Anit Pillai, Suri Prakash Reddy, engineer, assistant manager, Mr. Suraj Kumar, the host of this 4-day webinar series on latest trends on building construction and maintenance. I'm very happy that it is being held very successfully for the fourth day, and all the participants, such as the faculty members, are able to improve their knowledge, and the students are able to add with their knowledge, and the engineers in consulting engineers, members of ACCE, so improving their ability to deal with additional construction consultancy. With the help of these talks, they are able to gain some knowledge and experiences, because all these are veterans able to give the lecture very with the case studies, etc. Therefore, it's a field oriented and mix of with the faculty introducing the theme, and the other 3 members are on the field consulting in the area. It's a very good topic, and I thank the Ramco Siemens also for providing the platform, and very happy that this is going to be very successful, and welcome all the participants today. Thank you. Good day.
Thank you, sir. Let me just introduce the speaker of the day, Dr. V Rajedran, Secretary, ACCE Chennai Center. He has completed his BE in Civil Engineering at College of Engineering, Guindy, Anna University. Did his Masters in Structural Engineering. He completed his PhD in the field of corrosion mitigation, repair and rehabilitation of RC structures at Anna University, Chennai. He has vast experience which includes repair and rehabilitation of marine structures both within the country and also outside the country. He was honored as eminent engineer by Association of Consulting Civil Engineers, life member of Indian Concrete Institute, ACI Indian Chapter, Indian Society for Technical Education, Institution of Engineers. And he is presently the Director of High-Tech Concrete Solutions, Chennai Private Limited. And he is the Director of Concrete Quality Concepts, an IIT Madras incubated company. He is the Managing Director of High-Tech Civil Engineering Services, a company engaged in repair and rehabilitation of concrete structures. And he is also the CEO of TradeWinds, a trading company in the field of construction chemicals and the first multi-branded construction chemicals shop at Chennai. So with those few words, let me invite Dr. Rajendran, who would be talking about a very challenging topic because it has to be customized based on the problems. And that itself presents so many challenges. And we have seen that many customers are also very demanding. Once a repair or rehabilitation is done, always they would ask for guarantee. How many years will it last? So first is the practices they will not follow, then that will lead to repair, and then later on, the responsibility will fall on professionals like Dr. Rajendran, who would be asked for a guarantee. So over to you, sir, for the talk. Thanks for having come over here, accepted our this thing, and I'm sure the professionals will have a lot to take away. You can unmute your mic, sir, Dr. Rajendran, sir, and start off.
Yes.
Thank you so much, sir.
Yes. Thank you so much for a very brief and nice introduction. Today's topic is going to be brainstorming session on repair and rehabilitation of water structures. In fact, yesterday we had Dr. Nandathan was talking about in detail about what are the mistakes being made at site and why we get a lot of distresses and things like that. And as also rightly pointed out by Mr. Anil Kumar Pillai, the durability is not at all considered during the execution and during the new structures being built, which always eventually results in repair and rehabilitation in a larger scale. There is a say that once the repair and rehabilitation scenario has come or a structure is failing, we are not able to identify what should be the cause for the failure because we get number of complications and number of reasons why the structure has got failed. So in a nutshell, there is no single cause could be explained why the structure is failed, and every one of us will keep looking in a different direction. And for example, if you start looking at it, somebody says soil, somebody says the lateral dimension, the beam and the columns are not treated as well zone and things like that. And also someone says they remove few columns. And a number of things, but finally the structure has failed. That's known to every one of us. So there is no single cause could be explained after the distress has taken place or the collapse of the building has taken place, which is going to be a very, very disturbing scenario, which was not there in the past. So structure is supposed to be durable, sound and stable and also expected to be failure. On a contra to that, today we get a lot of failures and of late it is becoming very, very common than one can anticipate, as far as the failure of structures are concerned. Now we keep talking about modern materials and quality of materials, sustainability, increasing strength of the material, and also we got very sophisticated softwares which can do the best analysis and also design. With all this, we are supposed to do a better and more durable structures, but unfortunately, it is not the case. We are getting into a number of repair and rehabilitation scenario. Well before the construction is completed, we are going ahead of repair and restoration in the building which I will explain later. And this is not only in India, it is also in the world scenario, but of course, they have a lot of corrosion issue on account of the de-icing salt which is being sprayed over the bridges, and the car is going on to that bridge which contains the salt and it comes parked at the garage in any high-rise building. These salts are getting into the concrete slab, and then invariably all the parking slots in the high-rise buildings and then high-rise car parking decks having corrosion in other than our country where they have cold climates. In our country, yes, we have a lot of national highways and railway bridges. We have a large number of buildings in coastal areas like Chennai, Mumbai, and then Vizag. And sometimes poor detailing of concrete mix design is taking place, and it's information coming today that Mr. Anil was saying that you got 43, 53 grade of infra cement, and he's rightly pointed out, we discussed in detail one of the reasons why a lot of concrete cube strengths are getting failed because of the slum retention. And then of course lack of quality control because we are all the time in the fast construction and we want to. So with this, we can define a structure which needs to be rehabilitated, or a structure which is having deficiency. A deficient structure is one, or is defined as one, which fails to fulfill its intended function. It could be in terms of loading or in terms of durability. I'm going to design the structure for 50 years. Is it going to fail in 40 years? Or I'm designing a structure for a particular load which is not capable of taking this. If it is not able to take the intended function purpose, then obviously the structure is deficient structures which needs to be addressed. Now, normally people have got a little confusion over these four vocabularies like retrofitting, strengthening, repair, and rehabilitation. CEB-FIP very clearly defined this, retrofitting, strengthening, repair, and rehabilitation. I would say that, broadly classified into
But there is a problem in the sound, sir. If you can, come near the speaker and speak.
I'm talking. Is it okay now?
Yeah, now it's okay. I think probably you would be a little far away.
I have to hold this, and I'm using a headset. But retrofitting, strengthening, repair, and rehabilitation. I would normally say that we can make it into two baskets. One is retrofitting, strengthening, repair can come in one basket, and rehabilitation can be other basket. Now, what is the difference between these two? I have some issue. I'm going to derive a repair methodology, which I'm going to make it for the structure to use. When I'm addressing the repair methodology, if I'm also going to address the durability of the structure in terms of the repair methodology, then it can be called rehabilitation. If I'm not going to address durability in my repair methodology, then it can fall either retrofitting, strengthening, or repair. Again, retrofitting means modifying the functionality, strengthening, increase the strength of the structure, and repair, just bring back or reinstate the original strength alone. Or this is what these three categories. But it comes with rehabilitation, bringing the structures to its original or higher level of functioning, including durability and strength. If the durability is not being addressed in the repair methodology or rehabilitation methodology or in the system where we want the structure to put into use, then it cannot be called rehabilitation. Otherwise, it can be called strengthening, which falls under retrofitting, strengthening, or repair. This is what the general classification one need to have an idea when we derive the methodologies for behavior. Now, coming to type of disorders, they got functional disorder, we got structural disorder, minor, chronic, stabilized, and then progressive disorder. The progressive disorder falls under the category of corrosion, and which is going to be in a very, very huge size of market for rehabilitation is concerned as far as the progressive disorder is concerned. Normal procedure is we just go evaluate, do the analysis, find out what is lacking, the tensile, shear, flexure, compression, or as a whole member capacity. So for that,
Rajendra sir, sorry to interrupt you. Is it possible that you load the PPT, sir? Because I have muted your video because of bandwidth issue. The PPT is not loaded. Is it possible that you load the PPT, please? Because we've been getting requests for either the video to be switched on or the PPT to be loaded.
And I do not get it. I mean, the PPT is not, seen?
No, sir. No, sir.
Okay, what do you want me to do now?
You'll have to go to the. I've made you the presenter. You'll have to go to the third button, share content and share screen, like how we did in the earlier session, sir. Third button is share content.
Share content, yeah.
And go to shared screen, sir.
Share
screen.
That's also again third one.
Yeah, third button is share content. You click on that, the window opens up, and then in that the first one is screen 1. You'll have to click on that. And you can unmute it, sir, by right clicking on your name. Are you able to do it, sir? Rajanan, sir? Can you hear me, sir? Rajanan, sir, can you?
Yeah, but screen sharing is there, sir, on the third icon. Now you unmuted your mic. Suraj, can you unmute his mic?
Yeah, he has done it on his own. Okay.
No,
the
it's
third
okay.
button. The third button.
Yeah, share content.
Yeah, you'll have to click on that. A window opens up, sir. And the first one is share screen.
No, but now the window is not open.
Let me. I will shift the presenter role to myself and move it back to you. Let us see if it works then.
Yeah, fine.
1 second. Please hold on.
Yeah.
1 second. Okay, do it now, sir. 1 second. Yeah. Now you'll have to click on the third button. The first one is mute mic. Can you see that?
Yeah, correct. Second is video. The third one I'm clicking on, but it's not coming.
What is it?
Highlight. Share content. But when I click, nothing is coming.
Okay. 1 second, sir. It was working fine now, actually, until
it was working fine.
Now it's coming, I think. Now you just click on that share content.
1 second.
Now it is coming as Suraj, is it? Yeah.
No, I change it back to
Okay.
moving back to sir now. Ideally, now it should work. Sir.
Yeah.
Third button, share content.
Is it seen now?
No. Sir.
No. Okay. Share content is Now I have to start the first one.
Yeah, first one is share screen. That's
yes. Now it is coming.
Wonderful.
Now it's coming.
Yeah. Okay. Other than the speakers, we request other panelists to mute their videos, please.
Okay.
So when it comes to the strengthening process, we have to do the evaluation and then do the analysis and then find out whether the issue is the tensile, shear, flexure, compression, or as a member capacity itself. As a whole, it's not.
In fact, we are not able to see it. I thought it loaded. It's not getting loaded. I will do one thing, sir. I will do it again. I will move the presenter role to myself and move it back. You will have to do the same thing over again. 1 second. I'm moving it to myself now. 1 second. Okay. That's the reason. I will move back to Dr. Rajedran, sir. Change role as a presenter. It could be the issue. 1 second, sir. It's making okay. Can you try the same thing again? The third button, share content.
I don't know.
It's saying it is just starting to load, but it's loading.
You're able to see the slide now?
No, not yet, sir. I think it might take a while, actually. Is it visible at your place, sir?
No,
it
is
is visible.
Rajendran sir, would it be possible to mail it across to me if I send you my mail ID as we talk?
Oh, it's a huge file, no? I can, but it take a long time to do that.
Okay. What does it say, please, sir? When you click on share screen?
It has gone into the PPT, and then I'm able to see the PPT right on the screen, and then I'm able to see myself. My video is also over
there. Can you close all the PPT once, sir, and run it again? Ideally, it should have. Don't minimize it. Yeah, don't minimize. You can close the PPT.
I'll do that. I'm doing that.
I'm moving you away from presenter role.
I did it.
Okay. Try it again now, sir. You open the PPT first, minimize it, keep it ready, and then you have to go to share content. First, you'll have to open your PPT, minimize it, then go to the third button, which is share content, and then a window opens up. You'll have to click on the first one, which says screen 1. Share it through the screen. I see a blank screen.
Rajendran?
Yeah.
So initially you have put up some slides, you see, and you are talking with Suraj Kumar.
Yeah.
Now it was visible, now
that
it is not visible.
That time we did not have any problem.
Oh.
Please check.
No.
Okay.
Start sharing. You are sharing started, it shows me.
Can you stop sharing, sir, from your end? That is, you will have to move to the top center of the screen, a series of buttons will pop out, and then you stop sharing. Yeah.
Right side top.
Yes. Stop
No,
sharing.
audio connection, speaker, connect to device. Stop sharing.
It could be the first or second button. When you move the cursor at the top center of the slide,
Stop
series of
sharing, yes.
yeah.
Yeah,
Okay.
I did it.
Yeah.
I did it.
Yeah. Now you try doing it, sir. Sharing again.
I had to start the first one, first button.
Yeah, but it's not.
I got a screen 1.
Yeah, screen 1, please. Yes, wonderful. Okay, now I can see your screen. You minimize this, sir. I am seeing step 1 of 2, add WebEx to Chrome. Yeah. Okay, you can minimize this as well. Yeah, you can. Yeah, wonderful.
Yes.
Yeah. Thank you, sir. Should we start from the beginning, because we have missed out on the slide, sir?
Which slide you have missed out? This is okay. This is.
Yes. Can we start from the beginning itself, sir? Because
it's okay. Yeah, fine.
Yeah, we can do that. Not a problem. Okay. I'm sorry, man. Some technical issues have got confusion. I just go back. We are getting a lot of failures as of now, and then once the failure is taking place, we are unable to find out what is the single cause for the failure, because number of cases are coming together and saying that this could have went wrong, that could have went wrong, and things that are taking place. With this, we expect that the structure should not get failed, but as it is taking place, it is becoming a real disturbance for us. And it was not the case in the past. And we always wanted a structure to be durable, soundness, and stable. And we expected that to be a permanent one for us. But of late, it is becoming a very common issue that failure of structure is taking place now and then. We also have a lot of modern materials with improved quality and sustainability and increased strength. And we do have very sophisticated softwares where we are having good analysis and design softwares. But with all that, we are supposed to produce a better and durable structures. But unfortunately, it is not the case, and we are encountering number of failures taking place in the year past. This is not the case only in our country; it is also taking place in terms of abroad. And the only thing is that they are using de-icing salt, so durability is becoming a bigger issue. The cars which are passing the bridges carry this chloride, and then coming into the decking areas, the parking slots, and then when it goes into that, and those parking slots are also getting corroded on account of this de-icing salts, and then that is spending huge amount of repair and rehabilitation in terms of durability. Of course, as for the quality control and new construction, they have a better system of doing things. But even in India, if you look at national highways in the railway bridges, number of bridges are going to be rehabilitated as such. It has started. Even about 5-6 years ago, we did from Chennai to Pondicherry, about 18 bridges were rehabilitated because of the corrosion. Nothing else beyond that. A number of buildings in coastal zones like Chennai, Calcutta, Mumbai, Vizag is getting into a lot of issues. Poor detailing of concrete mix design is taking place. A number of issues like as Anil was saying exactly where it's information for me that Ramco has got an exclusive event for infra where you have a very high slump retention. People are trying to save some little money in the admixtures. They don't choose the right admixture, so they get into a problem of slump retention when they don't get the slump and they're not able to pump the concrete. As they're not able to pump the concrete, the tendency at site is to add water. Once they add water, water cement ratio is getting increased. Once the water cement ratio increases, they get reduced in compressive strength and resulting in a lot of issues. That is where we find that if I'm going to have a 10-story building, an 80-story building, 20-story building, when I'm doing my roof slab about 11-story building, I started doing a wrapping of the column in the 9-story building, 9-story and 8-story, because the cube has failed, posts have been taken, that also fails, and then there is no other go. We wanted to have the confinement in the concrete, so we start doing the wrapping. When my 13th floor concrete is going on, 8th floor is under repair and rehabilitation. Lack of quality control, yes, of course, now we are all into fast track construction, so obviously we get into this inevitable and we are having issues with lack of quality control too. So with this background, when you wanted to define what is a deficient structure is defined as one which fails to fulfill its intended function. I design a structure, I construct a structure for a particular purpose or a particular functionality. When it is not capable of doing the particular functionality, obviously we say that it is a deficient structure which warrants either repair, retrofitting, strengthening, or rehabilitation. When it comes to this 4 category, when you want to use this right vocabulary, CEB-FIP definition is very clearly says what is retrofitting, strengthening, repair, and rehabilitation. In my opinion, we can generally classify into 2 categories. One falls into that repair and retrofitting and strengthening. Another one falls separately into rehabilitation. What do we mean by this? When I'm going to do certain analysis and write a repair methodology for a particular structure, which is to be brought back to this original functionality, but I'm going to address durability also in the repair methodology, then it can be called rehabilitation. If I'm not going to address durability, I'm just going to do only in terms of strength aspects of it, either it can fall under the category of retrofitting, strengthening, and repair. Retrofitting, action to modify the functionality or a form of a structure or its component. Strengthening, again, is going to increase the strength of the given component or to increase the structural stability as a whole. Repair, action to reinstate the original strength. But when it comes to rehabilitation, bring the structures to its original or higher level of function, including durability and strength. We are going to talk about only strength, it can fall retrofitting, strengthening, or repair, or else if you are going to talk about durability also, then it can be called as rehabilitation. Otherwise, we are not supposed to use the word rehabilitation. Then when you wanted to get into the types of disturbance which is taking place, it could be a functional disorder, structural disorder, minor disorder, chronic disorder, stabilized, and progressive disorder. Out of all this, the progressive disorder mainly falls into this corrosion of organ structures, eats away the major chunk of GDP of this country, and number of structures are getting into this particular category because a proper maintenance is not being done in our industry, as already we are in a completely unorganized industry and the proper system for repair and maintenance is not given into importance. When the strengthening comes into picture, first we need to do the evaluation, do analysis, and based on that find out what is the deficiency, tensile, shear, flexure, compression, or a whole member assets. To do this evaluation, obviously we need to get into non-destructive testing. Normally, the causes of distress either it could be design deficiency. If the design deficiency, either underestimation of load, shear, moment, overestimation of material strength, overestimation of stiffness, omission of joints, poor detailing, improper mix design, and then faulty analysis. When it comes to improper mix design, we always get into an issue where we go to a particular place and we wanted people to say that now I want a concrete mix design. This is what the strength M45 I want or M35 I want. I want slump of 120 millimeter. What we fail to understand or what we fail to ask or what the design lab is also failed to give is what is the slump retention? Okay, you want 120 millimeter. How long you want this 120 millimeter? Is it for 2 hours, 3 hours, or 4 hours? When those details are not submitted or asked for, then we always get into improper mix design. As we said earlier, the water cement ratio outside gets increases. The other one is the material deficiency. It could be a contaminated water, expansive aggregate, reactive aggregate, contamination of aggregates, poor quality steel and cement. But of course, steel and cement poor quality, off late we don't have issue. But only the steel with 8 mm and 12 mm in our laboratory, we see that many of the steel is failing, but anything 16 and above 16, we don't have issue. So the contaminated water is becoming a big issue as far as places like Chennai is concerned. We have huge water scarcity and the water table ground level has gone down so deep, and when you draw water at that level, the quality of water is not that good and the water is not being tested and being used. And we have a practice that we don't go for an RMC because we wanted to have a column, we don't get 60 people at a time to be done. So we always use an in-situ mix outside and we use the water which is available outside, and that gets into a lot of issues as far as the contamination of water is concerned. Construction deficiency is inadequate cover, improper formwork, improper placement of reinforcement, excess water cement ratio, inadequate or over compaction, and inadequate curing. Curing is the most important. For the interest of students, I'm just trying to say why the curing is done, what is the curing is all about it. Suppose I've got a concrete of M30, I'm going to use 400 kg of cement and I'm going to use 0.4 water cement ratio, 400 into 0.4, I'm going to put 160 liters of water for making this concrete. All that what I want is this 160 liters of water should be available in the concrete for 28 days in terms of moisture. If it is available, then there is no issue. If this water is getting evaporated, then there is going to be deficiency and then the concrete is not going to gain the strength what it is expected to. Environmental effect, thermal effects, moisture movement, surface erosion, and hostile environment, and freezing and thawing is becoming an new issue. Earlier, thermal effect was not an issue like places like Chennai. Today, we have that. Before this pre-monsoon, like the situation like now, what happens is till April, May, the structure, ambient temperature is about 30, 40, 45 degrees, and then the concrete temperature is anywhere around 47 degrees to 48 degrees. And all of a sudden, in the afternoon, maybe around 3 o'clock, you have a shower, it falls onto the concrete where it is going to be an area like podium slab, and the temperature of the slab is coming down suddenly, where we get a lot of cracks in that. We encountered this number of cases in the recent past. Mechanical causes is of course overloading, abrasion, impact, wear and tear, and then fatigue. Chemical effect is going to be a durability issue, carbonation, chloride, acid, and then sulfate attack. These are all the issues which is taking place. The carbonation is becoming more predominant of late, that is the chloride attack, because we have a practice now. Once apartment cultures are coming to picture, we don't do the painting of the structures even for about 10 years and so, and obviously the carbon dioxide is getting reduced in the cover concrete and results in carbonation. And chloride, yes, we know places like Chennai is going to be predominantly on chloride, and this chloride corrosion is going to be more danger than the carbonation. Carbonation is loss of passivation layer, and then the pH value is getting reduced. Now carbon dioxide is getting diffused in the cover concrete. As the cover concrete is getting diffused in the carbon dioxide, pH value is coming down. The core concrete has got a different pH value, cover concrete has got a different pH value. The moment the carbonation level goes and touches the reinforcement, you get corrosion, and this corrosion is always an uniform corrosion. With respect to chloride, this pitting corrosion is the most dangerous one, because the chloride ions are going and then forming pitting, and then this makes a discontinuity in the rebar. There is going to be discontinuity. Obviously, the structure is going to fail all of a sudden without much of warning, and then it is an issue. The other one is a sulfate. Sulfate, we all know that reacts with the calcium hydroxide and C3A and forms this degenerate, and then it occupies a more volume. As it occupies a more volume, pushes the cover concrete, and then finally spalling takes place, and then the rebar is exposed to the environment, and then it results in corrosion. So the parameters for this is very, very important. Is the most one is cover thickness, and of course not only thickness of the cover but also the quality of the concrete in the cover region, and environmental conditions, pH value and chloride level in the concrete, and presence of cracks in the concrete surface, because that allows you to have a lot of pollutant to go in, and then it gets corroded. For the first 5 years, we don't have any issue, as the carbonation and chloride ions get penetrates into the concrete surface, and anywhere around about the 10 to 12 years, you get the onset corrosion is taking place. Once it goes beyond 20 years, obviously you get your first crack from that particular point, and then you get into spalling of concrete taking place as shown in that video. So the passivation layer breaks the is getting broken because of the carbonation and reduces the pH value, and chloride attack takes place, and then it also passivates the passivation and breaks the passivation layer over the rebar, and once the corrosion is initiated, corrosion is created and rust occurs at anode. Since the volume of the rust is several times greater than C, obviously the expansive forces are active, and then getting corrosion, which is a known fact to all of us. I'm just giving you a recap of it. The one thing is that we all follow limit state design, so where we talk about both durability and serviceability. Serviceability, yes, sustain the load safely throughout its lifetime. But what matters is, as a civil engineer, as a designer, we always worry about the strength aspect of its increase in physical property and physical parameters of the concrete, but we also need to give equal importance as far as the durability, which can be defined that ability of the concrete to resist changes in its microstructure and properties, which more often, chemical parameters. When we don't address this also, then we are not going to have a structure which is durable, although which is going to have the stable structure. Serviceability has to be read in line with the durability. For that, we always go with the non-destructive testing. Let me not dwell upon more on that. But situations where we need to go for non-destructive structures is that structures like this, which has got corroded. For example, the hydrothermal station at Kashmir, where because of the excessive vibration, only 2 units, one unit was functioning, and a situation like this at Kandla port, where one of the vessels is coming and hitting the mooring dolphin, and one of the pile wash off, or a situation like where this bars comes in due to cyclone and the pile column number 20 washed off. So we need to think of connecting this pile column 19 and 21 by connecting this with the truss, and then where you need to do the analysis and do for the non-destructive testing for the additional load of the column 20 be transferred to 21 and 19, whether these two columns are capable of taking. And then situation like this in a thermal power plant and a super thermal power plant with the TG dead concreting, or on a silo chimney where you have got an issue and already you have issue with respect to the setting of concrete because they're using the slip form. So the slip form movement is getting disturbed. So obviously you have issues inside the concrete. This sort of honeycombing is taking place, and where you need to do the non-destructive testing and then do this. Normally, non-destructive testing, yes, is going to be very useful, but what is more important is that the non-destructive testing is going to give some number, which is going to be of a number game, and these numbers ought to be definitely read with our best of engineering judgment, and which comes in the visual observation and documentation. So the measurement of geometric parameters of the structures need to be taken, because our experience shows that even with 5 years old building, if you go and ask for any details and data with respect to structural detailing, or even as per drawn, they are not available, and they say nothing is available, then we have to take it and then we need to get it done. But after that, you can decide for the non-destructive testing or partially destructive testing or load test, and with this you are going to have an interpretation and then do the analysis, the test report, formulate a repair methodology, and then once the repair is being done, also you have to do post-repair evaluation, thereby to make sure that whatever the system has been adopted is working well. When it comes to visual observation, we need to go with the width of the crack, whether the crack width is going to be more at the bottom, less at the top. All that including depth and length is going to give us an idea what sort of a failure is taking place. Is it because of shear, or is it because of deflection, or is it because of corrosion and things like that? And then restraining, spalling of concrete, dampness, drain, and then foundation detailing. We need to do all this documentation with respect to spalling, abnormal distress, discoloration, and then deformation. For example, I'm going to have a building going and doing an inspection of a fire accident building. The first and foremost is that you need to look for the change in color of the concrete, which gives you an approximate idea what would have been the temperature which has gone up during the fire accident. And the next is history of construction. Obviously, we need that, because once we know the history of construction, then we have to correlate with that particular point in time, what sort of the codal practices have been used. So what would have been the analysis and design methodology they would have done, whether is it satisfying for that first, and then let us look at it whether we are going to do the additional strengthening. So we need a history of construction, original quality, and also types of material which has been used those days. We all know that IS-133W was specifying part 1 and part 2 with the ribbon hammer and UPV. I need not dwell upon that. I just would like to make one statement on this particular aspect, is that in industry we have a practice where we wanted to predict the compressive strength of the concrete with a ribbon hammer, and it is not a right practice in our opinion, because we have a lot of different values. When you take a core and then press the concrete, you get a number which is nowhere relevant to the ribbon hammer number and prediction of that. If you have got a lot of data outside about a cube strength, and then if you are able to make your own curve, correlation curve, then probably we can think of that. Otherwise, having the curve is being supplied by the manufacturer, which always gives a very wrong details. For the reason, for example, I have a concrete which is carbonated already, and any carbonated concrete, if you are going to try to give a ribbon test, it will give you always 50 plus. With that, if you are trying to predict the compressive strength of the concrete, that's not correct, because the concrete is already contaminated. We cannot take that concrete as a reference one. Otherwise, also it is going to give you a simple detailing on the cover concrete, soundness, not definitely about the core concrete and FCK value. Then what inference we can make this number? Yeah, if I have a number 30 to 40, yes, I got a good layer of concrete. But again, this has to be read in combination with your anomaly indicated test if the concrete has got carbonated or not. If it is already carbonated and doing a ribbon on that and then taking a number and going forward with this number is not advisable. That's a point which I want to make, and I don't want to get engaged about it. As far as the ultrasonic pulse velocity is concerned, now earlier we had a different code, but now at least the code has come into picture with little more stringent quality. We all know that it can be done direct, semi-direct surface method. It is going to be a direct method. What we are going to do, where these two probes are kept right opposite each other. Indirect method, one your probe you are keeping somewhere here, the other you are keeping somewhere here, and then you are going to use the Pythagoras theorem and then calculate the hypotenuse, and that hypotenuse we are going to take as a path length, and then we are going to calculate the velocity of this contour. And this is going to be a surface method where you are going to keep both the transitions and the surface of it. As long as it was there in 13311 of part 1, we never had an issue. But now it has been brought to IS 516 part 5 2019, where it has been differentiated with two different grade of concrete. Earlier there was no talk about grade of concrete, whether it is going to be M20 or it is going to be M50. The guiding values are the same. There is no difference in it. But today, with the IS 516 part 5 section 1 says, if your concrete grade is less than M25, if your value is going to be less than 3.5 kilometers per second, and then the concrete is doubtful. But if it is for M25 more, then if it is going to be 3.75, it's going to be a doubtful. For example, I get a value of 3.6. If my concrete is going to be less than M25, then it can be inferred the concrete quality is good. But the same concrete, if it is going to be more than M25, if I'm going to get 3.6 kilometers per second, now it is doubtful that concrete cannot be classified into good. That's the difference what has been brought into this UPV once it has been given a modification to IS 516 2019. So this is a difference which I made, which I wanted to bring it to the notice of the practicing engineers and the students. Of course, next is a core test. Obviously, it's a partial destructive test where we try to do this and then trim it and then make the UPV and then brush it and then do this. Here again, what we wanted to emphasize is that when you want to do the core test, kindly remove the carbonated concrete at the top level, and then you go for testing this core. Otherwise, what would happen is the failure pattern of the core will not be the thing as we anticipate, because it is not a question of only get a number, 167.67 kilonewton has been loaded, but it is not only a number to define what should be the expected FCK value, but it also we need to know how the failure pattern has taken place in the core, which gives us lot many data. Of course, we all know that you have got a correction factor, but the core diameter is less than 100 millimeter, then you have to do it with 1.08. But practically at site, what happens is we never use 100 millimeter because the spacing of the rebars are so close, where we always opt to go for 69 millimeter or 76 millimeter, where we always use this as 1.08, and then 1.28 to get the equal constant. Here again, chloride sample is a simple collection of samples in centimeter laboratory finder. What is more important, again, we need to be clear as a practice engineer. Please do not collect the powder sample straight away 0 to 75 millimeter, collect it and then test it. You always go for incremental of 0 to 25 millimeter, 25 to 50 millimeter, 50 to 75 millimeter. So you know up to what depth the chloride ions are penetrated. So up to what depth I had to remove the concrete cover or remove the contaminated concrete when I write my repair methodology. Otherwise, what would happen is if the 0 to 25 has got, let's say, 1.5 kg per cubic meter, and 25 to 50 has got about 0.7 kg per cubic meter, and 15 to 75 has got only 0.2 kg per cubic meter, and all these three levels of powder is getting mixed, then you get a different powder sample which would have 0.59 kg per cubic meter. When you test at the laboratory, it will give 0.59, and then we go happily, yes, it is within the threshold limit of 0.6 kg per cubic meter as per IS 456. So that should not be done. So we need to go in a different level. If the concrete is going to be, the structure is going to be very, very important, then you can go even the incremental of 10 millimeters, 0 to 10, 20, 20, and so on. This is a very simple test, the coordination test. I would say that it is not a test, or every repair contractor who is going to do the job should have this, indicator at site. As he keeps checking the concrete, you need to spray the pinocchio indicator. If there is no change in color, pink in color, then further he has to chip off. Otherwise, we will not be able to remove the contaminated concrete completely. And then keeping the contaminated concrete and then doing a repair and rehabilitation is not advisable. For example, in this case, the carbonation is already taking place around 40-42 millimeter. So when you write the specification, let's not write the specification like remove the loose concrete or to go up to the strong concrete is getting achieved. As we discussed earlier, definitely a carbonated concrete will be always a sound concrete. But although physically it is good and physically it is a good, sound concrete, but chemically this is not advisable. So that has to be removed. For that purpose, we do it. So always, this an entity has to go in combination with 1 or 2 or 3 tests, and then we have to come to that conclusion. The other one is offset potential, where we are going to see the rate of corrosion of concrete, where we follow this, reinforcement, where we follow this ACCE 876. At FIP, we always go with the proper copper sulfate. This is a process which is being done. Many of you are familiar with this, where you are going to connect the steel through a multimeter to the concrete cover, and where you are going to use a copper as your reference electrode. And for making the connectivity, you are going to fill with that super saturated copper sulfate solution. Thereby, you are going to read what is the flow of electrons of current taking place. If it is going to be more than minus 350 millivolt, obviously we know that it's more negative minus 350. The corrosion rate is more than 95%, and between 200 to 350, 50, and then it is less than 5%. Here we come to the conclusion is how soon I need to take up the rehabilitation. Can I wait for some time, or it is so urgent that we need to take it immediately? That sort of inferences we can. Performator survey, as I said a while ago, we normally do not get any drawings at site, even 5 years old building, even government buildings when we go, we don't get these drawings. So when we don't get these drawings, obviously we need to go for this. So this gives you what is the cover thickness at the appropriate plate, and it gives you what is the diameter of the rebar, and then it also gives you the spacing of the rebar. As I said earlier, all this is going to be a number game, and we need to definitely use our best of engineering judgment. For example, the manufacturer gives you a detailing where they say that whatever the diameter of the bar you are getting, this could be one bar size number more, or it could be less, or some of the manufacturers say 25% will be the plus or minus. For example, I got a rebar, it shows me 16 mm diameter of the bar. It could be 25% less. So 25% of 16 is 4 millimeter. So 16 minus 4, it could be a 12 millimeter diameter bar, or it could be 25% more. So 16 plus 4, it could be a 20 millimeter diameter bar. So again, with the best of our engineering judgment, we need to look at it. What is the diameter of the bar? And for few places, nothing wrong in chipping and physically seeing at least 1 or 2 places the equipment is giving me a proper reading or not. Based on that, we'll be able to come to a conclusion. At this place, it gives you 75 millimeter the diameter and thickness of the car. And the last one is a pile integrity test. What we do is we keep an accelerometer. It's called pickup or otherwise, and you're going to have an instrumented hammer. You're going to hit it 6 times, 6 places all around this, and then you do the test. It gives you sort of a figure where you get the depth of the pile can be calculated in any neck formation, or it's going to have any of the bulging has taken place in this pile. When you do this testing, what we do is that we need to give one input. What is the input we need to mandatorily give is that you have to first fix what is the velocity of the concrete. So normal practice is that we fix it 4 kilometers per second or 3.5 kilometers per second. So that we are assuming that the concrete is expected to be good. With that velocity, we are going to calculate and we are going to say what is the depth of the pile. For some reason, the concrete is not having that amount of velocity, then obviously your pile length calculation will be wrong. So again, what we need to do, better to take a core from that pile, check actually what is the velocity of the concrete, take that output as an input to be given in your pile integrity test, and then you'll be able to get a right depth of the pile. So what I'm trying to say is that with one single test, let us not try to conclude. It should be in the combination of 1 or 2 tests, and also with our best of our engineering judgment, and then we go for it. I just wanted to place 2 case studies. One is a simple one, which I'll show you on the durability. The other one is on this structural rehabilitation, where we did it for one of the building in Chennai, as Chennai has become from zone 2 to zone 3 upgradation. Now this building is in Chennai again. It's got a 3 years old building. It has got corrosion. You can look at it, underneath this, sunken portion, but more so in the columns. It's got 8 towers of 17 floors, or 3 years old. When we did this half-cell potentially, because no other issues were there, it was only corrosion. So we resorted to half-cell carbonation, then powder sample, and half-cell reading is about -357 to 420. Of course, carbonation was only 10 millimeter. That too in the basement where the parking is being done. We all have a practice, and even our drivers have a practice. The moment they start either the car or bike, they try to give more of acceleration, and you will find a lot of exhaust. The smoke comes in through the exhaust, and then the column is faced over that as it gets spreads, and then carbonation was there, and it was about 10 millimeter. But on a contra, the chloride was about 1.05 kg to 2.52 kg per cubic meter, and the depth was also more. So contaminated concrete chloride, then we will not be able to remove all the contaminated concrete, and then if you want to remove 75 millimeter, column of about 300 by 300 or 300 by 450, if you want to remove 75, that's at 75, then 150 goes up. Then out of 300, I get only 150 millimeter for concrete, which is not advisable. And without removal of chloride ions, it's also not advisable to leave the structure in terms of durability. So what is being done in practice is that anodes are being used in a simple system. I just wanted to simple, throw some light on it. I'm not going to discuss in detail. So go do the proformity survey, find out where the main rebars are there. Just cut open this area where the rebars are exposed, and then tie this anode to the steel. In this anode, what you have got is about a zinc inside, about 55 to 60 grams of zinc, depends upon the type of anode which you are going to use. And this anode is covered with a very high pH lithium matrix, which is going to act as an activator. Now, what happens when I connect two metals together? It's going to result in difference in the two metals are connected. Obviously, bimetallic corrosion is going to get initiated. Once the bimetallic corrosion gets initiated, obviously the corrosion is getting shifted from steel to zinc, because zinc always oxidize much faster than the steel. That is what your galvanic series table gives you. Only thing is, you need to make the important aspect is that you need to ensure that connectivity between the steel and the anode takes place. You can find the moment the steel and anode is connected, the circuit is already formed, the current starts flowing. You can find the anode is placed over there, and there is no anode here, it's just touching the steel. You find that current starts flowing in, and then it's going to be most useful in terms of corrosion resistance is concerned. We all know that connectivity in a structure 99.99% will be established, otherwise the stress flow will not take place. You can find anode is kept here in this column, the nearby column is being connected, still you find the circuit is getting established. So this is a system of late, is being used in the industry, where these anodes are placed at a regular interval and you don't have any issue. This particular site, about 1,773 anodes have been calculated. How do we calculate? We have to calculate the spacing of these anodes. How do we do the spacing of the anode? Is that you have to calculate the surface area of the concrete and surface area of the steel to be protected. With this, we get a ratio called steel density ratio. Based on the steel density ratio, we can do the spacing of these anodes. As of now, about 257 anodes have been installed, and on account of this, pandemic situation, we will not continue further on it. And probably by sometimes August, we should be in a position to do it. If someone is interested, students also, you can come and then have a look on it. So with this, I'm just concluding as far as this part of the construction, presentation is concerned, where we have a word that let us construct a healthy and then durable structure, and then I go for a case study. If there are any questions, now we can take it up, or otherwise we can take it together at last as a whole. I'm just leaving to organizers to take a call on that. Is this visible?
Yes, sir. Please go ahead. We can have the questions at the end, I suppose, sir.
Yeah, fine. Thank you. One of the things in our retrofitting issue coming into picture is that change in codal provisions. Chennai was in the zone 2 till 2005, and then thereafter it has been shifted to zone 3. The moment it has been shifted to zone 3, and there were mandatory conditions, especially for the public buildings, they need to strengthen these buildings for zone 3. We did one for at Kuralagam at Paris Corner, and then two more at IIT Madras, where the Sharavati Hostel phase 1 and phase 2 has been done. Very recently, we have done for one such buildings in Mylapore, where it has got a 30 years old building, which has got a basement and then 3 floors. On account of the zone 3 conversion, and they wanted to go ahead with this zone 2 to zone 3 conversion, and we did as usual simple NDT test. As far as this particular aspect is concerned, for converting it to zone 2 to zone 3, what all that we want is a few quarters back, we wanted to have the FCK value of the concrete, and we need to do proforma survey to get reinforcement detailing, as they didn't have this reinforcement detailing of the particular structure. So we have to do GA drawn and then we do this profoscope. Of course, initially the survey has to be done, testing has to be done for soil. So we did a soil test and then collected a sample and then what is the bearing capacity of soil. And then it was a RAP. So we wanted to know out of this RAP, what is the shoulder they are given and what is the net area which is being there for the soil pressure calculation. We have made out the digging and then found out that. Then of course, we did core extraction to get the FCK value. We did this scope and proforma survey. As I said, at least one or two places, physically you chip open and then find out what is the actual diameter of the bar with the vernier, so that you can read in combination of this. Otherwise, as they say, 20% variation, that gives a huge difference in the percentage of steel, and then we get into misleading inferences. Of course, as being it is a 30 years old building, we also did a few places approximately velocity, and collection of powder sample for doing this chloride concentration. As far as the concrete is concerned, at 22.6 and 22.5, it is deemed to be M25 because we use this the clause 17.5.3 of IS 446, where it says your average value is going to be 0.85 times of the FCK value. Then you can deem that divided by 0.85 or 1.15, then you get multiplied by 1.5, you get the grade of concrete. So with this value, we are going upon to finalize that it is an M25 grade of concrete. And then with the proforma survey, we had different elements have been scanned, and then we calculated, we have documented what is a rebar detailing, and then we have calculated what was the percentage of steel, and for that percentage of steel, and what was the load carrying capacity or moment carrying capacity, and for that moment carrying capacity, assume the end conditions, and for that particular end condition, for this moment carrying capacity, what the load carrying capacity was there for that industry. As for the soil test, it is revealed that the bearing capacity of the soil, safe bearing capacity of the soil, is 180 kilonewton per square meter. And assumptions what has been made for the giving the input, the analysis of the software is grade is M25. We know that what has been arrived is 22.6, so deemed to be M25. Grade of steel is 8415, and SBC is 180 kilonewton per square meter. Reinforcement detailing as found in the reinforcement survey, and also cross-examined by chip opening and then finding out what is the reinforcement available in that case. Seismic zone 3, the load along loads combination or as follows. What has been the method adopted is do the design check for the existing building without infill for seismic zone 3. Obviously, it is likely to fail. If it is going to be safe, it's very fine. If it is unsafe, then again you go for the next design check with the existing building with the brickwork, that is an infill as a diagonal strut. We all know that code is giving a very clear formula where you need to find out what is the brick bearing strength and the mortar which has been used, that is M1, M2 or H1, H2, and based on these data, we will be able to get what is the width of the strut, and make an analysis whether this width of the strut, whether it is going to be safe or not. Even if it is going to be safe, then there is no issue. It means with the for the frame structure, with the diagonal strut, the brickwork is going to act as a diagonal strut for the calculated width of the diagonal strut. If it is safe, then it is fine. If it is unsafe, then again we go for the design with the methods for the zone 3 and then recommend the proper design methods. So the design was carried out for the in-situ material properties as said earlier, only for the frame, and then one with the brick wall with the equivalent stud build. So this is the loads taken: dead load, live load, seismic, and then wind load. Unit weight of the concrete, unit of the masonry, and then the live load is taken about 4 km per square meter, and terrace was 1.5, star is 4. This was the interest of the students. I'm just saying, otherwise it is not required. Seismic load, we all know, is very simple. BP is going to be a simple formula where we are going to multiply with the AH, and AH is what we are going to calculate. Otherwise, W is going to be your seismic lump mass, AH into W, For the AH, you got different parameters given in the code, like CB code zone 3, what you are supposed to take, zone 2, what you are supposed to take, and what is a temperate, and things like that. But here you need to understand one thing is that as far as temperate is concerned, zone 3 normally we have to go for the dynamic analysis, not the static analysis in general. But the code has given you a condition where up to 15-meter height, if you are, normally we go with the static analysis and for zone 2. But if it is going to be zone 3, we can also go for static analysis if the time period is going to be 0.4 seconds. If it is going to be more than 0.4, then you don't have a choice of going for a dynamic or static. Then you have to go for a dynamic analysis. In this case, what we did is only about 0.25. So then we went on for the static analysis, and then the design was proof checked by Professor A.R. Shankumar and certified for construction, including the rehabilitation methodology, and then it has been executed. Wind load has been taken 55 meters per second, and then these are all the K1 to K4 factor, and then the parameters. The load combinations of that in this manner is probably well what we knows about it. The first is slab check. Slab check was found to be very satisfactory. Actually, we didn't have an issue over it, and this was the thickness of the slab and what we need and what is available, and everything was okay. And then the slab was deemed to be safe, and we know no rehabilitation repair is required to be done for the slab. As for the soil bearing capacity, the LB calculated is 180, and the total mass is taken and raft size is taken. The soil pressure is about 81.12. So as far as the soil is concerned, absolutely not a problem. And as it has got a basement, it has got a RC wall in the basement continuously. So obviously you have an advantage over here as far as the structure is concerned. You've got a shear wall, a continuous shear wall already building up to the basement level. And only when it comes to the column, it is a frame stand alone. This is a single frame moment without infill was taken, and shear for a reference. And second modeling was done with the strut, and then you do the with the infill where you are going to calculate the width of the strut is going to full wall thickness or half wall thickness, and that has been taken into account, and then we did there again we had a failure. So the repair methodology, how we started looking at is that first, let us provide a shear wall at the re-entrant corner, at all these 4 corners of the building. Yeah, and also the stair well, you provide a shear wall from basement to the top floor, so that with this shear wall introduction at the re-entrant corners and at the stair, do the analysis and look at it whether it is capable of taking for this zone 3 horizontal forces. If it is the case, then let us look at based on this additional load which is coming on to this, because we introduced the shear wall in concrete, any other beams are failure or any columns are failure, and then for those columns and beams, let us look for doing it. So look at the modeling. Straightforward, we are giving a shear wall for these re-entrant corners, and then the in between you find the strut, which is nothing but the brick infill, which has been converted to the equivalent width of the strut, and then the analysis has been done, and we found the moment as drastically reduced, and it is capable of taking the horizontal shear. But of course, we had more load momentum shear coming to the beam on account of the additional load system which has been reduced, and shear also got reduced drastically. So based on this, we designed the shear wall, and this is a detailing of the shear wall. Column diameter bar with 180 millimeters in the center of the direction, and it has been anchored into the top beam and then the bottom beam or floor beam, where we have created the fixity condition. As far as the sides are concerned, it has been anchored into the columns. This is a detailing. They also wanted to have a few openings, and then when you want to give an opening, if there is a column, then there is no issue. Otherwise, we reduce the stiffness where we don't want to have the stress flow, free stress flow, and then we wanted to confine that, so we introduce this. On account of this, as I said earlier, the new load has come. These beams had a failure, and these beams need to be strengthened, and few columns are failed, about 1, 2, 3, 4, 5, 6, 7, 8, 9 columns are failed, and these 9 columns and the other beams needs to be strengthened, and once it is done, the whole strengthening system is the structure is put into action for zone 3. So when we calculated, then you take out the all the RC beams and columns, and then we went to the 2 combinations, one with the microconcrete jacketing and other with the CA-FIP rafting. When it comes to microconcrete jacketing, how we go about it, if the concrete is going to fail, as a member itself is insufficient, and definitely there is no point in going for a CEB-FIP wrapping, then we need to go with your increase the thickness of the depth of the member, either a column or it's going to be the beam. Otherwise, you can very well go with the CEB-FIP strip and then CEB-FIP wrapping. If I say that in general, if you are going to have a deficiency as far as the flexure is concerned, the most right candidate would be a carbon strip and then carbon fiber wrap. If it is going to be on account of member section failure or it's going to be compression, then we need to go for the additional strengthening with the jacketing. As far as the CEB-FIP strips are concerned, you have got two systems. One, you can go with a near surface mounting, or you can simply strip the fiber sheet or the strip onto the concrete surface. It is always better to go with an NSM because it's going to act as a part and parcel of the concrete member, where you are going to make a sleeve and then you are going to insert this carbon strip into that and then finish off with an epoxy glue. What matters here is that if I don't get the proper cover thickness in the real structural member, then I will not be able to go. For example, in the design, I'm going to introduce 1.4 millimeter wide and 22 millimeter long width strip. Then I need to have 25 millimeter cover thickness minimum to insert that, or at least 30 millimeter. If the cover thickness is going to be only 10 millimeter to 12 millimeter, where I want to do this NSM with 1.4 by 25, which is not possible, then obviously we need to go for just sticking onto the surface of the concrete. One biggest advantage when you are going for NSM is that you are going to add an additional advantage of increased moment of inertia or Z value, because in this case B is going to be 1.4, D is going to be 25. In the other case, B is going to be 25 and D is going to be 1.5 in this case, where I'm just sticking onto the surface, the 25 millimeter is going onto the concrete surface, and I also need to go with one more layer of wrapping because the failure should not take place because of the debonding of these strips from the concrete member. When it comes to strengthening, then you have to go with the stick this fiber strips, and then in between gap you have to fill with an epoxy glue, and then you have to go for a fiber wrapping problem. You've got a case study I'm going to show you, this will be more detailing. As I said, your compression C is going to be low than T, then your CEB-FIP will not be able to come into the picture as far as the beams are concerned. Maybe for column, yes, it is all right because you are going to wrap all around the column, you are going to get in the confinement, then it should not be an issue. As far as compression is concerned, in a beam, then there is no other go. You have to jacket you have to increase the depth of the beam, wherein you are going to provide a shear connector and then do the additional reinforcement and then provide additional shear reinforcement and then make the jacketing, for which you have to provide a pour from the top of this and then pour the micro concrete over here. As for the shear keys depth is concerned, you can calculate what is the maximum bending moment of the beam and then divided by lever arm, then you get the force and you predetermine what should be the spacing of your shear connectors, divide by the number of shear connectors, and then you get what is the force which is coming in a single shear, and based on the bond strength, you can decide what should be the depth of the shear piece, because that's going to be more important. Otherwise, the micro concrete and the parent concrete will not act as a single element, it will act differently. So this has been followed. So the repair system is erection of shear wall is the first one, which to take care of the seismic forces, and which is satisfying, but it is not satisfying because the dead load is increasing. It is resulting in failure of few beams and columns. So carbon fiber wrapping has been done for the columns, and then jacketing has been done for the beams, and few beams which is not failing on account of compression. It fails only because of flexure. Then it has been done with the carbon strip. So this is the system how it is being done for the carbon use, and this is the shear wall how it has been done at that particular site. As it is being 30 years old, there were also few corrosion taken place, and those corrosions have been also addressed by installation of additional reinforcement, because where the rebar has got corroded less than 50 millimeter original diameter. And as I explained earlier, self-sacrificial anodes have been installed and micro concrete jacketing has been done over that. Carbon fiber wrapping. Why always we prefer a carbon fiber wrapping is that we all know that we've got an age-old system of steel plate bonding technique, and then member enlargement, the additional micro concrete jacketing or FRP. For a given case where I wanted to increase 35% accreditation of a live load for a flexural member, if I'm going to use a steel plate bonding technique, I'm going to add additional dead load of the member about 112 kg for 35% increase in live load condition. If I'm going to use a system with micro jacketing with two numbers of 800 diameter bar and with about 100 mm grout, I'm going to add about 1134 kg of dead load into the system for increasing 35%. But the same 35% increase in live load condition, if I'm going to use an FRP system, I'm just going to use 2.72 kg dead load, where my design will be most economical and easy for installation too. So that's the reason always you prefer to go with FRP. If it is not possible, then shift it to any of these two systems which is available and it's already proven track record. But of course, that's one disadvantage of FRP, because FRP system always goes with an epoxy glue as a adhesive, and that goes, you have got a fire issue. You can very well address that also. So we are grinding the surface, making the surface to be very fine. After the grinding, you can find that epoxy putty has been applied. We'll have a pure system. It's going to be a Pakka 0-0, because what is the bond between the FRP system and concrete is very, very important. If there are going to be a few holidays, then that's not going to be a proper bonding. And when there is no proper bonding, the adjacent area will have stress concentration, and there is every possibility the FRP system can get delaminated. Once it gets delaminated, the whole purpose of the whole rehabilitation system would get failed. And then you are going to apply an epoxy primer. This primer is expected to penetrate into the concrete surface. As it gets penetrated, it is going to act as a part and parcel of it. As this is an epoxy primer, I am going to use an epoxy glue for fixing my strip, or it's going to be a wrapping. The primer is being an epoxy. My epoxy glue adhesive is also going to be an epoxy. So there's a like-to-like material. So bonding is perfect. So we are making sure that the bond is perfect. So you have to choose always a primer and the adhesive of the same family. Otherwise, you will have a problem of debonding. And then it is being wrapped with this case is about 230 GSM fiber wrap is being wrapped. So where you are going to get a confinement, and then you are going to increase the strength of the concrete. Once it is wrapped, this is how it looks. After the wrapping is completed, we are going to apply one more. Here, what they are trying to do is they are using a ceramic roller to release the entrapped air, if any, so that the bond between the concrete and then the repair methodology system which has been addressed is having a perfect bond, so that it is taken care. As I said, you have one disadvantage of fire. It comes into the picture, and then if the structure is expected to be outside, then you have got UV degradation is likely to take place, because epoxies are not suitable for ultraviolet rays. So what you can do is that you can apply one more layer of adhesive, and then you can take a sharp sand particle, sprinkle it over the surface so that gets bond to that. On top of it, you can either go for a normal plaster or you can go for a gypsum plaster. Depends upon your fire retardant property which you are looking for. In this case, this has been done with a normal plaster. And now coming to the beam for the CFRP, what it has been done, we had an issue of cover thickness. Although we are supposed to have a 20 mm cover thickness, we had only about maximum of 15 mm, and there are places we are only 8 mm. So we were not able to go with an NSM. So we went with the CFRP strips onto the bottom of the beam, and then apply epoxy glue in this beating area so that the entire surface will be uniform, which will reduce your CFRP wrapping without much of issue. As I said, first is the strip, and then applying epoxy putty in between this gap of the strip. After that, you have a carbon fiber sheet wrapped in the shear reinforcement direction. One is that it will not allow the debonding of the strip, and also it enhances the shear capacity of the beam. What all that you need to do that, like normal component steel, where we do the detailing of development length. Here also you have to calculate with the bond length, and then to that level of that length, you have to take this wrap onto the slab, and then you have to finish off. This is how it has been done. Again, removal of entrapped air, and then sprinkling of sand particle on this surface, and then doing the plaster. Column, yes, done with the additional CFRP strip and also with the wrap, and then it has been done with the regular plastering. And this particular industry did not borrow for gypsum plaster. It is going to be a regular industry. Maybe let's say a cement plant, then it is advisable always to go for a gypsum plaster, not to go with the regular plaster. So the repair system is such: before introduction of your shear wall, you need to strengthen your beam and then the column, and then come to last as a shear wall, because your column and beam is should be capable of taking over your load, and then you introduce an additional load. As we said, the re-entry corners have been broken, and the brick wall is being broken at the corner levels, and whatever the openings have been provided are removed, and then drill holes for providing the shear or inserting your rebar onto the floor beam, similarly onto the roof beam, and cut the rebar and then make it in such a way that first off of it with the development length calculation or the LD, the slab beam has been inserted with the reinforcement, and subsequently you are drilling on this, and then you are connecting, and then you get the development length in the alternative direction. This is how it looks after the rebar has been fabricated and put into position. You can find the lap is not at the same level, it's at a different level. One bar will come from top and one bar will come from bottom. Similarly, from one column you will have left to right and right to left, and then you will have the development length taking place. This is a detailing image. They did order to have few openings in the shear wall itself. So those openings, what we are providing is an additional stiffness in the form of beam has been provided where they wanted to have an opening, and also we have a couple beam on top of this opening in the form of stud, so that it takes care of to reach the requirement for our zone 3. And overall, it will be like this. These areas you have no opening, and I have got an opening. You have a couple beam to have to arrest your short column effect, and also you have additional column stiffener coming into along the side of the opening. This has been followed, and again waterproof ply formwork has been provided, and it has been done. With respect to concrete, now we cannot go for a normal concrete because the first link has been done, the second link will go up to the top of it. And if you want to do a normal concrete, then I have to do the vibration. When I want to do a vibration, I have to use a 40 millimeter needle. This will be about 450 mm long, and then I need to have some working space. I need another about 300 mm. So about 750 millimeters, I cannot do the concreting in a proper manner because I need to go from the top of the beam up to this. I have to do the compaction, so it is not possible. So we went with the SEC self-compacting concrete with 0.39 water power ratio, and a binder about 450 kgs. Out of this 320 kgs with the cement and 130 kgs with a fly ash, and we were able to get 650 millimeters spread, and then we were able to pack up. In addition to that, we also added the aluminum powder where we don't want the shrinkage to take place between the soffit of the beam and the new concrete which we are going to lay. So these are new the formats have been done, the first layer, and then the second stage of concrete is done. It has been taken up to the top, and then just break open and then pack it in the existing beam, and then start pouring this SEC, and you have absolutely no problem as far as the contact between the soffit and the is concerned. I'll just show you. This is how you will have the contact between the existing beam and this. There's no crash, nothing. SEC as such will go up to the top, and then you will have not an issue. And then you're going for a membrane-based curing compound. They not use water curing, they use acrylic-based curing compound, and there is no issue in that at all. Again, in choosing of a curing compound, there are two parameters. Either you can go for a wax base or you can go for an acrylic base. It's going to be a wax base, it's cheaper. But only thing is, if you're not going to go for further painting, if you're not going to go for further plastering, you can go for a wax base. If you're going to go for further painting or you're going to go for further plastering, then you can choose always an acrylic base where bonding is not an issue, or else you will have a bonding issue. Probably in infrastructure projects, yes, you can go for water-based wax base, but for regular, you can go for an acrylic based. This is about the jacketing, what has been done. You mark the area, you go the plaster, and then you just look at the cover thickness. Once the plastic is removed, absolutely there is no cover at all. Only plastic was acting as a cover, and then look for the corrosion, and then provide additional reinforcement as per the design calculations. And then as you have got a corrosion, we also provided these anodes which has been put into place, and then this has been Now you can find the anode has been provided and then cover block has been provided and the anode has been verified, and on the top cores have been made for pouring this microconcrete. The beam bottom has been put and sides also been placed, and once the beam bottom and side is placed, from top you have to pour this microconcrete mixed and then pour continuously. What is more important is you have to maintain the hydrostatic gate. For maintaining the hydrostatic gate, you need to have some system like this. That is an 100 mm thick runners have been provided like this. As you start pouring the microconcrete continuously, you need to maintain this 100 mm level at the top so that you are making sure that the hydrostatic pressure is maintained and the microconcrete is being poured, goes from one side and then goes to the other side. There is no problem in the soffit of the slab is concerned. After a removal of microconcrete, you can find a perfect joint between the slab soffit and the beam side microconcrete. For this purpose, you need to maintain this arrangement where you are going to have a simple arrangement like this. If you need an hydrostatic, the beam depth is going to be more, then you have to increase the height of this so that your hydrostatic head pressure is increased, so you don't have any problem at the bottom of that. After that is a regular system, like where you are going to redo the infills and then do the plaster, and then you finish off the plastering or whatever you want to do. What is more important is that when you are going for a column with a system with the CFRP wrapping and then things like that, I'm just searching for one slide where I can making sure that okay. When you are going for a CFRP wrapping, one of the biggest advantages, even if you go for 400 millimeter thickness wrap, the repair system is going to have additional thickness of just 2 mm only. When it is going to be 2 mm, you won't find at a later date whether the column has been, whether the column has been done with rehabilitation or not. You will not be able to find it at all. In the case of microconcrete jacketing, we all know that 100 mm thickness it will go, and you will not be able to. Obviously, you have to increase the size of the member. Any other system in steel plate jacketing, or you are going for microconcrete jacketing. Because steel plate jacketing, you need to be very cautious as far as the corrosion issues are concerned. So this is how this building has been rehabilitated from zone 2 to zone 3. This is during the rehabilitation process, and once everything is completed and it has been handed to the user body. Thank you so much for the opportunity given to share my experience, where our job is working to do repair and rehabilitation and then do the non-testing. And now the floor is open for the questions.
One attendee was asking about your email ID. I think email ID, it can be noted. It is there on the screen itself.
Yeah.
Yeah. So that's nice. It was a very nice presentation. In fact, you had covered the limitations of various kinds of non-destructive testing, which was very relevant, because one should not jump to conclusion based on those tests alone, and we need to have a combination of tests and then various other techniques. It was very interesting. Can we take few questions, sir?
Why not, sir?
Dr. Shiv Kumar K, excellent presentation and quite useful. Please provide guidance on installing CP, corrosion protection, for new structures.
Yes, sir. In fact, we have been working on it, and so what we need to have is we need to have a general at least reinforcement detail. For example, I have a beam span of let's say 7 meters, 6 meters, and what could have been expected a percentage of steel I am going to use, and then what is the diameter of the bar I am going to use. Based on that, I need to get a rough idea about the surface area of the steel to be provided. Based on that, we'll be able to design the spacing of the anodes. Otherwise, it is going to be an issue. If it is going to be an anode installation, very simple. All that what we need to do is that more important is the connectivity between the anode and the steel. If that is being addressed in the methodology, absolutely there is no issue about it. Otherwise, nothing goes wrong as far as methodology is concerned. One thing, additional advantage is you can also monitoring the system whether it is working or not. What you can do is that you can take one lead from the anode and other lead from the steel. You connect it to the corrosion monitoring box, and then you can keep monitoring the corrosion with an offset potential reading taken at a regular interval, or you can take only simple the current values monitoring box, where you need to get at least about 80 to 100 millivolt difference between the shunt potential and the on potential. If that is addressed, yes. And I think Dr. Shivakumar is talking about a particular project. They are working on it. myself and Shah will be going back onto that case.
It's very useful because many of the structures which are near the marine areas, especially coastal areas like Chennai, it would be very relevant. Another question by Mr. Venkatesh. Sir, rebound hammer value may vary if we take readings from top and bottom of slab. Which one is correct value? Because slab top surface cement mortar may reduce the rebound reading. You have already covered this, but you can emphasize on the point.
Yeah, as Anil said, exactly it has been covered. First and foremost, we don't want to take the strength of the concrete with respect to rebound hammer. And why the variation is taking place is because your aggregate settlement will be taking place at the bottom, so distribution of aggregate will not be a proper one. So you better choose, that is where the SCC is coming into picture, which modifies the viscosity. And also, as I told you earlier, Ramco has got a different grade of, different types of cement for a different purpose. So if you are going to go for an, pouring of your concrete with a very high, maybe about 2 meters or 2.4 meters, things like that, expected aggregate settlement is obviously going to be there. So better you change your cement, you go for the advice of, people like Ramco, where they would advise you what sort of cement you can use, where it changes the viscosity of the concrete. Thereby, you are not allowing the aggregate to settle down at the bottom and only the cement matrix at the top, where it's going to give you a different in rebound. Probably you can make a trial and error. Maybe in the middle of the member, you can try it out. You may get a number which in between the aggregate and the mortar. Probably you can carry forward that as far as the concrete cover parameters are concerned.
Mr. Ashwini Shri Kantaya wants to know what grade of epoxy is used in repairing.
See, actually, the grade of epoxy, normally what the code says as far as repair and rehabilitation is concerned, suppose if I'm going to have M25 grade of concrete with existing structures, you go 1 grade more or you go 5 MPa more. For example, I'm using M25, so I go for M30 grade of concrete or M30 grade of concrete. That's how we go. So even your epoxy also, you should have 1 grade more. You should not go more because the modulus of elasticity should not be too vary between your existing structure and the new material which you are going to use. So the modulus of elasticity should be more or less equal. So it is always advisable to go for 1 grade. If it is an epoxy, normally the epoxies are M60, M70 grade. Even polyester resins are M70, M78 grade. As far as this rehabilitation is concerned, more than looking for a compressive strength, please look for the bond strength between the concrete and the epoxy. The code wants at least minimum 2 MPa should be the pull-off test result should come. If it is going to be less than that, then it is not advisable.
And the costing of such epoxy repairs, can you put some light on that?
Suppose if I am going to go with the CFRP repair is concerned for a column. Yeah, when I'm going to go with the CFRP repair, as far as a column is concerned with the 230 mm GSM or 450 GSM, the cost would be anywhere on about 4,000 rupees to 4,200 rupees per square meter on the surface area of the column. As I was telling, the case study, when I'm doing a 10-story building, my 9th floor being concreting is being done. 4th floor already I'm doing the wrapping of this column because they already added water at site because they didn't get the slump retention. Water cement ratio has gone up. Now my concrete strength has come down. I take a coat, that also comes down. So when I want to do this particular place, this column is not a freestanding column. So I will not be able to break out and then go for a new column concrete. Or I cannot go for a jacketing for 2 reasons. The size of the column will get increased. If I want to do that, again, I cannot do only for that particular floor. I have to go 1 floor up and then 1 floor down. So with all that, if you compare the costing, the CFRP wrapping would work out very, very economical because you are doing complete confinement. Your triaxial force is going to get increased. The reaction is going to be more, and then you will be able to meet out the requirement of the textile. So you can take roughly about 4,000 rupees to 6,000 rupees, depends upon what thickness of the fiber sheet which you are going to use as far as the wrapping is concerned.
Again, another question, I think already you have answered this by Dr. Shivakumar again. CFRP wrapping, is it more easy to do in circular columns?
CFRP wrapping is more and more predominantly most useful, not only easy, sir, it is more useful and more, you get a maximum advantage if the configuration is circular in column. If it is going to be a square, any case we have to make all the square corners into 25 millimeter to 40 millimeter radius and then you are trying to make it a little more of in a circle because it is going to have a proper stress flow. And if your column is going to be rectangular, again you need to do this. If your column size is going to be L by D is going to be more than 2, then the CFRP will not be able to give the expected results, because when it goes to more than 2 L by D, it's not going to act anymore as a column, it is going to act as a shear wall. So you will not get the enhancement of the strength as good as the first choice in the circle. The first result will be for circular, second is for square, third is for a rectangular where the L by D is less than 2. If it is more than L by 2 is more, then the result of this will be gradually coming down from circular to rectangular having L by 2 more. You are right, sir. For circular, you will have the maximum benefit in CFR.
This is a very challenging question by Karthikeyan. Is it possible to increase the 30-year-old building plinth level?
Is it possible to increase
the 30-year-old building plinth level?
It is possible. There are a number of structures have been done even in Chennai. There is an exclusive team working on it. They are able to bear. We have a system. Unfortunately, the government bodies have a system. I buy a plot today. I construct my house. The difference between the floor level and the ground level about 600 millimeter. Having an opinion that yes, 2 feet is all right. The corporation or any other government agency keep on doing the road without removing the existing layer. And one point of time, my building goes below the road level over a period of 25 years to 30 years. Probably you are asking a question which similar to that kind of an application. It is possible we can lift this structure by another 600 millimeter. To the present road level, again it can go up to 600 millimeters. It can be done. People are doing it even for the load bearing structure. Absolutely not a problem. Number of buildings have been lifted like this at Chennai.
It's very interesting. Another by Ms. Punita Kumar. For column strengthening, we have micro concrete and FRP. Can you share your views on merit and demerit of this material briefly?
Yes, micro concreting one. Start with the table. The design is very easy. You are going to use a limit state design, and then you are going to provide an additional reinforcement, and you are going to increase the size of the member. As the area is getting increases for the particular given load, your stress is going to get reduced. So obviously, it's a very simple as far as design is concerned, and in fact, execution is also easy. So that's the advantage of it. What is the disadvantage? When I'm going to provide an additional reinforcement and then increase the size of the member, as I increase the size of the member, my floor space is getting reduced. So to that extent, the commercial area we are going to do. For example, our 10 years back, we did one project right opposite the Bangalore Majestic, bus terminus. They had a theatre called Sangam Theatre. The Sangam Theatre was converted into a commercial complex. When they wanted to convert into a commercial complex, they wanted to go for a different methodology. When the methodology was being derived, when the column size all around we had increased about 100 millimeter, they objected for it because those days the cost of the selling cost at that place was about 18,000 rupees per square foot. Right opposite the Majestic, the number of floors and every column is increasing. Then they calculated we are not interested in going for this. Then they went with the CFRP strip and then the wrap. So that's one of the disadvantages. The second disadvantage is going to be people think that is economical, but it's really uneconomical because when you are introducing additional reinforcement, the reinforcement already there in the original concrete. Normally, it is not being taken into account because when you want to take the lever arm, from the one face of the column face to the extreme end of the rebar, we always take the extreme end of the new rebar which you are providing, but the rebar which has been provided already is not taken into account. So again, you have to provide same amount of steel put into face. So third, all the columns normally will not fail. Only few selected columns only will fail. So you will find that this column is having a different size, that column is having a different size. Again, a number of floors is going to be there, and you got a different moment of inertia. In case of your seismic forces, you are going to have a different mode factor failure because you get a different size, you get a different moment of inertia. So stiffness is varied. So these are all the disadvantages as far as this is concerned. With respect to CFRP, you can do it very fast. In no time, you'll be able to complete it, and then the thickness of the member is not going to increase. You can remind you have the same thing. The only disadvantage is in terms of fire. If you are not going to have a proper fire protection system, you will have an issue. And people, when they are going to disturb for some other reason, we all know that, once a AC installation agency comes into the picture, you do not know. They take course left and right in the beams. We did one building in at Vellore very recently. They completely cut the rebar at the bottom of the beam at the midspan, and there is a deflection. Cracks have come, or because they wanted to provide a drain for the AC pipeline to come. All that they know is they want a slope. So initially they start with a different level at the beam, and then at they come to the 19th beam, they cut the rebar and then they go off. That sort of a situation, this may not be advisable. So you have to take that. This is only little disadvantages. Otherwise, you've got more of advantages as far as the CFRP systems are concerned. And again, CFRP not necessarily be carbon fiber. You can go with glass fiber also. If you want to, your requirement is only ductility improvement, don't go for carbon fiber. You go for glass fiber, which is much cheaper than even a carbon fiber. It can be done maybe about 1,800 rupees to 2,000 rupees per square meter. Not an issue at all, which is locally available. Only carbon fiber is being imported. Glass fibers are locally available. You can, it depends upon what is the requirement.
Another question, is there any IS code available for durability test, inspection methods for old structures, estimating the life of structures, various repair methodologies?
As a durability, Anil sir has already covered, water permeability test is one test which you can, think of how the out porous it is. The moment durability comes into the picture, there are only two things. One is the carbon dioxide is going to get decreased. If a cover concrete is going to be highly porous, obviously you are going to have issue. So take a core and then do it. The second one, if it is going to be in a new structure or if it is going to be an old structure, again Anil sir has already covered. You take the core, slice it, put it into your RCPT, look at what is the coulomb it is passing through. Based on that, you can design. Based on this, you can design a repair methodology. If it is going to be a simple corrosion, you can chip off and apply an anti-corrosive coating to the rebar and then you do a patch repair. If it is going to be more of issues with the chloride is more, your RCPT values are more, your carbon dioxide diffusion is more, your permeability is very high in the concrete, then you resort to a system something like our anode, where at least for sure, to 20 to 30 years, you will not have any problem. Another biggest advantage of the anode installation system is that even after 30 years, you don't have to do a repair system all again. You have to simply go to the particular place, cut open, remove that anode, and then replace a new anode. The job is done. So those systems can be done. With respect to modeling, there are a number of modelings are available, like 365 and things like that. But again, it is only a number game. We don't depend upon that as far as the life expectancy of the structure is concerned. We are not sure about it. How these life prediction models are working, which are freely available. Probably if somebody can working on it already for maybe last 20, 30 years, probably we can make an interpolation curve and then decide how this life prediction model can give us a data to us.
Yeah, with the kind of construction practices that we encounter, I think it's really very difficult to predict their lives. Last question, sir. Nowadays, by using various capacity jacks, the buildings are being moved from one place to another place. How safe are they? Is it acceptable practice satisfying codal provisions, if any?
See, as such, there is no codal provisions that are available. If you ask whether acceptable procedure, practically people have been doing it, and normally we all know that what works, what matters. That is how we go. Even there is a doctor who is more knowledgeable. When you go there, he gives you something, but it doesn't work. When a doctor is less qualified, less experienced, whatever he specifies works, you always prefer to go with a doctor who has got less qualified, less experience, because what works, what matters. So as of now in the industry, what works, what matters, people are adopting it, people are doing it. And there were not much of failures have been reported as on date.
So that was a real brainstorming session that we had. And there was one statement which was made by Mr. Karthik, and he was saying that Singapore currently they are using CRPF method rehabilitation, the 50 years old building for G+11 foundation, something like that. You say. I think Singapore it is being used.
It is. Even in India it is being used. We are following a code for design ACCE 442 or 2017. Code is being used, but for shifting it from one place to other place, in India, code provision things are not available as of yet. Thank you, Karthik sir.
Thank you so much, sir, for your presentation and clarification of questions. So, if there is any more queries or anything related to your contact details, can we give it to the attendees, professionals who ask for it?
Please, that is only sharing of knowledge. What we gained, we got it from the industry. we want to share back to the industry. Nothing else more than that.
Because I think there are a number of queries being asked as to when we can contact the speaker and all that. So we will just give your email ID, sir, so that
Please,
they can.
Please, sir.
Thank you. Thank you so much for that wonderful presentation, and it was nice to have you. The series of presentation that we had over the last 4 days that we had on building maintenance and construction, it was really very interesting on all the various aspects of construction. And it was very practical, like say, for example, this repair rehabilitation. In fact, so many customers or so many professionals keep asking us whether this can be done or that can be done. And I'm sure that this is a very niche area where many professionals cannot make a mark actually. That is what, because it is not very common and very less number of people come forward to take up these challenges. I think high-tech has done a lot of work in this area, especially under your leadership. And I'm sure that especially for Chennai residents, they have got this kind of information that is readily available and they can always easily accessible. So thank you, sir, for that wonderful presentation. And thank you, ACCE Chennai Center, for organizing this series of talks, especially the chairman, Dr. Tirunaka sir, and yourself, secretary, Dr. Rajedran, as well as treasurer, Mr. Vinod Raja, who has really taken a lot of initiatives, in fact, to organize this webinar. Because I'm sure that civil engineering students, if they take it in the right spirit and work on this, I think the future is bright. So this pandemic is not an excuse for us not to improve our knowledge. In fact, we can keep our gray cells working, and I am sure that this would be a very positive. This would have a positive effect on our physiology, and I am sure our immune system will also further strengthen if we engage ourselves in such fruitful activities. So thank you so much, and thank you ACCE Chennai, and thank you Mr. Surya Prakash Reddy also, who had in fact interacted with the speakers from our side. And thanks Mr. Suraj for hosting that, and as well as being patient with so many this thing, but we could finally make it, and that is what is very important. And at the end of it, we had a successful series of webinars. With those few words, let me take leave of you. And thank you, Dr. Rajedran sir, and wishing you all the best. I'm signing off from today's event. And we
thank you so much, sir.
Yeah, please,
yeah.
sir.
Yeah, I thank Ramco, Siemens, and then Anil sir, and also Surya for this arrangement. And I first thank our chairman, because he was the one who initially asked me. I said, the same topic I need to give. He said, doesn't matter, but you can give one more also, not an issue. Probably you can change one more case study into it, and that was input for me. And I did not present other case study which I did last time. And I make an appeal to all the students. This area has got a huge potential. If someone wants to become an entrepreneur or someone wants to get into this, please do start thinking on repair and rehabilitation rather than getting into a new structure. So with that, I thank once again Ramco and ACCE for the opportunity given to me. Thank you so much.
So tomorrow we meet at 11 a.m. again for another webinar by Professor of Nikmar on testing of construction materials. So I sign off from the event from today and thanking you all the best. Thank you, sir.
Thank you, Suraj too.